Betelgeuse, also known as Betelgeuse, is a red giant star in the constellation Orion. If our Sun were in space, its size would extend past Mars and reach the orbit of Jupiter. This massive star is so unstable that its brightness is so variable that scientists believe it will quickly explode in a supernova. The Betelgeuse explosion, when it occurs, is one of the most powerful explosions ever seen in the universe. These supernovae release more than 1 billion suns worth of energy, making Betelgeuse a fascinating science project. What makes Betelgeuse so remarkable, besides its size and excitement, is its orange color and its contrast with one of the brightest stars visible from Earth. The star is classified as a variable star, meaning that its brightness changes over time and increases in appearance. At times, Betelgeuse is so bright that it can rival or outshine some of the brightest stars in the night sky, attracting the attention of amateur and professional astronomers alike. The scientific community has been puzzled by these differences, leading to speculation about the timing of Betelgeuse's explosion. Although the phenomenon of a star going supernova may seem strange, it is a topic that excites astronomers. This burst allows us to fully understand the life cycle of the stars, and although Betelgeuse's burst can create a spectacular light show, it poses no threat to Earth as it is 642 light-years away. Considering Betelgeuse's size, if it replaced our Sun, it would not only swallow Earth, but extend beyond Mars into the asteroid belt between Mars and Jupiter. The star's amazing appearance dwarfs Earth on a global scale. Despite its terrifying size, the Earth is safe in the shape of Betelgeuse. This red giant, although close by astronomical standards, is far enough away that the explosion will not affect us. Neil deGrasse Tyson and other astronomers have observed that a star's brightness varies for many reasons, including its size, temperature, and distance from Earth. Betelgeuse has seen dramatic changes in brightness, especially in recent years. The most obvious depression occurred in late 2019 and early 2020, a situation that made many wonder if the end of his life was near. The word Betelgeuse has a very linguistic origin that goes back to the Arabic language. Over time, scholars debated the origin of the custom, but the current spelling and pronunciation is widely accepted. Betelgeuse belongs to a group of stars known as red supergiants, which are some of the most massive stars in the universe. Located in Orion, one of the most recognizable constellations in the night sky, Betelgeuse is easily recognized for its characteristic brightness and color. Betelgeuse is one such planet. Unlike other stars that belong to clusters or star-forming regions, Betelgeuse is relatively isolated. A star is classified as a flying star, meaning it has been ejected from its original location and is moving rapidly through space. Despite its isolation, Betelgeuse's size and brightness have made it a major target for astronomy. Betelgeuse is so massive it has 764 times the radius of the Sun and 16.5 times its mass. Despite its large size, it is much cooler than our Sun, with a surface temperature of about 3,600 K compared to the Sun's 5,778 K. However, Betelgeuse's cold temperature does not diminish its brightness. In fact, it shines about 126,000 times that of the Sun, which is an indication of how much energy it radiates. Although Betelgeuse is still a young star, only 10 million years old compared to our Sun's 4.6 billion years, it has already burned through its core fuel. Stars like Betelgeuse tend to live and die very young, and Betelgeuse is nearing the end of its life cycle. When it finally explodes in a supernova, it releases an enormous amount of energy. The eruption is visible from the ground even during the day and may last longer than a full moon for several weeks. If Betelgeuse explodes, it will leave a remnant, much like stars that have gone supernova before. These debris contain material left over from the explosion, often creating heavy elements such as oxygen. These remnants give astronomers valuable information about what happens in the time after a star dies. For example, the known supernova remnant, G292.0 plus 1.8, contains high concentrations of oxygen and other elements that were created in the star's core before the explosion. Betelgeuse's event in 2019 caused widespread speculation and has since been called a large-scale mass ejection. During this event, a large portion of the star's outer layer is ejected into space, creating a dust cloud that obscures the star's light from Earth. This mass ejection is significantly larger than the coronal mass ejections, CMEs, we see on the Sun, which contains 400 billion times more material. These massive launches are just Betelgeuse's way of surprising scientists and offering new avenues of study. One of the biggest challenges for astronomers is determining the exact distance to Betelgeuse. Although it is 642 light-years away from the first estimates, new calculations suggest that it is 724 light-years away. These different measurements are due to the difficulty of observing red giant objects, which are often covered in gas and dust, making accurate measurements difficult. Despite uncertainty about its exact distance, Betelgeuse is still one of the brightest stars in our sky. Its energy density is about 100,000 times that of the Sun, which means that it will quickly use up the last of its nuclear fuel. As Betelgeuse nears the final stages of its life, astronomers are watching. The future prospects of the Betelgeuse supernova are not only for scientific research, but also for public interest. When this star finally exploded, everyone could see it looking up into the night sky. For a short time, Betelgeuse outshines all the stars and planets and can be seen during the day. This cosmic spectacle will continue for several weeks as Betelgeuse fades from its original brightness. The last supernova observed in our galaxy was in 1604, an event known as the Kepler supernova, named after the famous astronomer Johannes Kepler. But even that supernova occurred in another part of the galaxy, far from Earth. Unlike Betelgeuse, which is relatively close, Kepler's supernova didn't surprise us here on Earth. On the other hand, Betelgeuse offers new astronomers a unique opportunity to study the immediate aftermath of such a big explosion, providing data that will help improve our understanding of stellar evolution, the dynamics of the world. For years, scientists have studied stars at different stages of their life cycle to understand what causes a supernova. Supernovae occur when a star runs out of nuclear fuel in its core and rapidly collapses. The outer layers of the star are then blasted away in a violent explosion, leaving behind either a neutron star or a black hole, depending on the mass of the original star. In the case of Betelgeuse, scientists predict it will leave behind a neutron star, a small, incredibly dense remnant that is just a fraction of the size of the original star but immensely heavier. When Betelgeuse explodes, it will emit vast amounts of radiation across multiple wavelengths, from visible light to X-rays and gamma rays. Fortunately for life on Earth, despite Betelgeuse's proximity, the star is located far enough away that the radiation will not pose a threat to our planet. However, the event will be carefully monitored for its potential to provide insights into the mechanics of radiation from supernovae, which can have profound effects on surrounding space environments. Astronomers believe that the Betelgeuse supernova is a Type II supernova, the type that occurs in massive stars like Betelgeuse. These types of supernovae are characterized by the collapse of the star's core after the explosion of its outer layers. These types of supernovae play an important role in the recycling of the universe's elements, as the explosions throw heavy elements such as carbon, oxygen, and iron into space. These elements are necessary for the formation of planets and ultimately for life itself. In this way, the death of a star contributes to the birth of new systems and fills the universe with the necessary building blocks for the formation of future stars and planets. The exact time of Betelgeuse's eruption is unknown. Despite recent events and the excitement they generated, experts warn that Betelgeuse could continue in its current state for tens of thousands of years before exploding. Stars like Betelgeuse, especially those nearing the end of their lives, are invisible. Although the star may seem to be nearing his peak, he may be entering another phase of his difficult life cycle that in recent years. Astronomers have used instruments such as NASA's Hubble Space Telescope and other ground-based observatories to monitor Betelgeuse's oscillations. Hubble, with its unparalleled precision, has been able to detect subtle changes in the star's atmosphere, allowing researchers to create more accurate models of what is happening within Betelgeuse. Other technologies, such as infrared telescopes, are also being used to see through the layers of dust and gas that often obscure the most critical processes happening in massive stars like Betelgeuse. Betelgeuse's supernova, whenever it happens, will also have implications for our understanding of the future of our own Sunday. While the Sun is a much smaller and less massive star, the general principles of stellar evolution apply across different types of stars. Studying a supernova like Betelgeuse's would provide clues about what will happen to stars as they reach the ends of their lives, especially in understanding the late stages of stellar evolution for massive stars versus more modest stars like the Sun. However, the Sun, with its relatively low mass, will not explode in a supernova. Instead, it will swell into a red giant and shed its outer layers, ultimately leaving behind a white dwarf dead for Betelgeuse. Its final moments will be one of the most anticipated events in modern astronomy. When it does explode, it will be one of the brightest and most magnificent sights humans have ever witnessed in the night sky, rivaling or even exceeding historical records of supernovae in our galaxy. This cosmic explosion will not only provide a spectacular visual experience but will also flood observatories with data that could take decades to analyze and fully understand. In summary, Betelgeuse remains a cosmic enigma, a star that is simultaneously a symbol of the grandeur of the universe and a reminder of its violent, ever-changing nature. Its upcoming explosion is a major event in the history of the planet, witnessing the explosive death of a massive star. Until that day, scientists will continue to monitor Betelgeuse and wait for signs that the end is near. Until then, Betelgeuse will remain one of the most popular and studied stars in the night sky, where astronomers are experts.